Did anybody just register because it's a workshop, or you guys know what this machine does?
I have no idea what the machine does.
Okay, I like that. Okay. Don't give it away. Okay. Oh, I haven't?
I can print a circuit.
Okay. Okay, printing circuits. All right.
I don't know how they work though.
So let me pass these around. Let's start with this. Let's pass these around here per table. I guess we have 3 tables. You get one for your own.
Assistant.
Oh. Okay. So what you have in your hand, what happened?
It's a ruler, right?
It's a ruler. Well, you got to ask Louis about that. It is a ruler, but this ruler was created with this machine. And what the ruler does, it just shows what the machine can do. So the machine can drill, the machine can print, and we're going to walk through the steps to what the machine actually does. But the main thing that this does, it's a PCB 3D printer. It prints on PCB boards. And what a PCB board is literally stands for printed circuit board. That's what PCB stands. Some of you might hear PCB. I got a PCB board. I can buy it at a Micro Center. I don't know if you guys ever hear that. PCB is the most common word where you're holding in your hand the actual name of the board before anything was done to it. Even after it's done to it, it's called a PCB board. Okay? So that printed circuit board. And what this does, it's like a 3D printer, but it's 4 circuits. And why is it important? Because, well, think about when you want to do, who uses microcontrollers, like Arduinos? Who's heard of Arduino before? Yeah? Okay, you guys definitely use Arduinos. Raspberry Pis?
Yes.
Who uses a computer? Okay? Even the motherboards and all these parts inside every single electronic component ever would be made of some sort of bigger version of this. This is more like a friendly tabletop version. What we have in the industry, what the industry uses, are called pick-and-place machines, or fast-paced pick-and-place machines. Once you look at them, they're insane. They're the size of that table. On average, they have them way bigger, about this table. And it has an arm that if you stand in front of it trying to see where the arm is moving, you can't trace it with your eyes. It's how fast it goes. It literally, what it does is it pick and place. It picks components, say like, I have more stuff in there. So let's say you see all these little gold parts. You see all these like kind of goldish color parts. Components are supposed to sit on there. It's what would really happen here. And you put some solder paste, you heat it, and kind of glues itself together. And what that machine does, it has something like this, and it picks the components or the processors or the whatever, and will put it into its place. And in like seconds, it does a whole bunch of boards. It's insane how fast it moves. Later on, whenever you guys have some time, go to YouTube, just type in pick and place machine, and just see how fast these things work. Who's been to Maker Faire before? There was a whole aisle just for pick and places. I don't know if you've ever been or see these big machines with a whole bunch of electronics parts. It goes, it's crazy how fast it moves. It's like, I'm amazed at it. I know I'm going too long at it, but I'm amazed with these machines. They're insanely fast, and that's how we build most of every electronic component similar to this. In computers, 3D printers, screens, phones, most of them would go on a machine like this. And it would just fast produce them, so fast. And then what it does. What happened? Yeah, well, technically you can make a Raspberry Pi or an Arduino out of this if you buy the components. All the components that you see on the top that are sticking out are just parts that you can buy. You can make your own board. And what also the good thing about this is we have breadboards. And what a breadboard is something here. So let me pull up a picture because I know if I say breadboard, it might not seem that familiar. But if I let me see. Have you guys seen one of these before? Yes. Okay, so this is what a breadboard does is when you're prototyping things and trying things out, you can just put a couple wires, so the way this would work out is that this whole line is kind of connected. And we can go deeper into this. That would be like a whole separate course. We can go an entire course into how all these work, Arduino's how to program Arduino's. Vito actually did a mini course, I believe, on it, and I heard a lot of good feedback. So whoever was in Vito's class knows what this is and how it works. It's just bridging things between each other. So you can connect multiple signals to different locations, having the same ground, and so on. This is not what we're doing today. What we're doing today is how you're going to make your own custom breadboard. Or if you say, let's say you need a part where you need 3 wires to go in a certain route, and then you need to print a different part right on top, or you need to connect your own circuits in your own way. You don't need all the extra holes or the extra bulkiness. You can make it all out of a board this size. I believe I have them here. Perfect. So we have a couple types of boards, which we will talk about. So this is one of the larger size boards. This is just a blank PCB. It's blank, it has nothing. That's what you would put on this machine, and in there you would print and drill and whatever you got to do out of that process. That's our blank PCB. So now, since I spoke enough and kind of think, let's see. Nope. So industry does not use a machine like this. This is more for small prototyping, smaller parts. That's what a PCB machine looks like. Over here, it stores all the components. You can see some chips right onto here, and it's just a whole roll of chips. And what I mean by chips, like microchips and controller chips and so things like that. You can keep it there, it's fine. And then it just feeds it through, and the arm literally comes, picks it up, puts it whatever should belong on a circuit or whatever it might need. So that's how it works. Just kind of so you get a better idea about this. Yes?
Can you put this dirty into the table, or will it damage?
You should always work clean.
Okay.
It won't damage anything. What do you mean by dirty? Like, is it like
Because there's a little bit of a...
Yeah, it's a little bit of stuff.
like a fingerprint?
Not fingerprint, but like eraser stuff. You just got to stick into it.
You see, this is not bad. This will print okay. Always clean it. Always work with a clean surface. It'll make your print in anything, whether it's a plastic 3D printer, welding, or this. It doesn't matter. Always working clean will give you a better result. Now, even this, just like 3D printing, this is just a tool. This machine only follows orders that you create from a CAD software. And computer-aided design doesn't only mean 3D modeling, like for 3D printing. There's also circuit modeling. Like you can actually build your own circuit, which you need for this machine. You can't just, how are you going to explain to it what do you want? The way you would do that is with a computer-aided design software. And the most famous one is called Eagle. Eagle. And Eagle is created by Autodesk, which is the same people that created Fusion 360 and AutoCAD. And I'm sure you guys have heard of AutoCAD. Some of you heard of AutoCAD? Someone take the AutoCAD course here at Bergen? Yeah? Okay. So yeah, Eagle is one of the most popular professional software used in the industry for this type of work. People that design parts in the pick-and-place machines literally use Eagle. So that's kind of like the go-to software. So Eagle is very important. You have to, look, the learning curve is a little bit steeper than in like learning Fusion 360 because it's a little bit less graphic. It's a little bit like you don't see the 3D modeling. You see a lot more. You see the part and you build it and you can extrude from here and cut from there. You can go, and this is more of like it's a 2D thing. So some people find it easier that it's 2D. Some people have a hard time looking at 3D. In my experience, I feel like Eagle is a little bit more of like a steeper learning curve. There's a little bit more of a steeper learning curve when it comes to Eagle because you have to know the component parts. You have to know how big to make the pads, or what's a through hole, what's a via. Yes?
Will you have any course for that then?
Sure. I mean, it is in the works. It is in the works. I'm not sure when it's going to, like, we don't have a date for when it's going to get launched, but it's definitely in the works. Yeah. So that's a good question. Again, you can totally self-teach as well. There's one of the best things about Autodesk is that they have a huge resource library online for self-teaching, self-paced teaching. You can just go Autodesk Eagle and you go to download the software, which is free, by the way. For students, it's free. And even for, if you one day you want to open your company when it comes to circuits, as long as you're making under $100,000 a year, it's free. So make sure when you do your taxes, you're at $100,000 a year. So yeah, that's the nice thing about Autodesk. And YouTube. Autodesk have their own channel on YouTube, and like 10 videos come out every day. It's insane how much really they're stepping up their game. I believe that Autodesk, like I thought for a while Autodesk was, getting old, but they're definitely stepping up their game. So that's something to keep an eye on. self-teach, they have tutorials from no experience to then project-based learning. Literally, you build a project and then so on. So that's something else to keep in mind. I just wanted to make sure that you guys know that this, without a CAD program to install onto it, is not, it won't give you anything. There's some samples, I'm sure there's some libraries, but how many of you were there for the 3D printing workshop? Because I mentioned Thingiverse. You guys remember Thingiverse? Thingiverse is like a huge library where it has a whole bunch of STLs for you to print. Well, in this case, there's not that many files out there. You can always find some, but there isn't that many. So now something I want to mention when it comes to this machine, something you guys should know. These boards are two-sided, and you can print on both sides. Once you set up the job on the one side, you kind of have to stick to the one side until you're done with everything. Then you got to flip it over and then go to the second side. But this is called a two-sided PCB. In this machine, it's a two-layer machine, so it can actually print both layers up and down. And you can connect a circuit going from the top to the bottom. So you can have a line powered right from this corner, and then you can have power feeding through to a component down here. So we can do that. And there's ways to do that. We'll talk about them in a little bit. But just like, remember in 3D printing, we say STL is the file that you need. In here, it's these are the two file formats that this thing would accept. And this file format is, so Gerber is kind of like the format for circuit printing, period, right? So this is that's what the G stands for. It's like a standard for circuit printing. And then the T would send you the top or bottom for the bottom one. So top or bottom of the actual layer. When you actually put your code in, it's the top or the bottom, and from there, this just stands for layer in both cases. So when you have a two-part, or you only have a one-part, when you only have like a one top layer, then you only probably export a .gtl, which is top layer. So remember that. That's what that would really mean. But other than that, it's top and bottom layer. There is more to it when you go into drilling holes, which we're not going to get into today. I just want to get through the basics today. I just want to get us to be able to successfully print one sample print, which they have built into it. We know there's some extrusions to do. You have to tune a couple things. But these are two file formats that you have to know. It's like STL, right? Saying in STL, you know what the machine accepts. This is the two files that the machine would accept. There's more files. These are, and again, this machine is called, the company that makes this machine is called Voltera. And Voltera have an amazing website. They have every resource. They have a whole bunch of frequently asked questions, which are really good. And when you email them, they're very quick to turn around. So even if you have a question and you can't find it, you can just email them directly, and they usually will turn it around within the next day. So this is kind of like the compactability. You guys will see what solder paste is and drill. We're not here yet. We're not on these two yet. We're probably all we're going to do today is really just the top one. But just so you guys know, you can go into all these extensions. But the most famous ones would be the top and bottom layer. So, setting up the machine. I'm done talking, I'm done doing the background. Let's actually get to work. A couple things you guys gotta know. This is what the machine really comes with. Okay, so these components you have to get familiar a little bit with. So this part right here, which actually let me pull it out as I show you guys, and we can pass them around. Okay, so a nice thing about this machine is that most of these components, since you consistently have to put in and off, take one in, put the other one off, it's magnetic. So the way this will attach is just, you put it in, it's just magnetic. So, and when you're done with it, you just pull it out. So it's easy, that actually has a little easy factor. And it's quite sturdy when it comes to these two. The drill, not so much, we're not gonna get there. But this, once you put on, it's not gonna go anywhere. Okay, so this is called the probe. This is the part that the probe measures the height of the PCB. So different boards will have different heights. this diameter right here, or this length, this distance right here, this changes between boards to another boards. And the way the machine knows where the top is, because remember, this is going to print right on top with a tip, or like a nozzle, that has such a fine tip that even going in a fraction of a millimeter deeper than what you should, it'll break the tip. They're that sensitive. So having this mounted to the board firmly and having this exactly probed the right, take its time probing and make sure you probe it right, you will easily, without question, break the tip. So make sure this process is done correctly. So the probe measures the Z height of the PCB. That's what the probe does. It measures the Z height of the PCB. I can pass it around so you guys can take a look.
It's called a probe?
Yeah, that's a probe. Yes. So as that gets passed around, this right here is kind of like the cartridge that holds the ink that we will be using. And that is like, it almost works like a syringe. So it's a two-part. It's a two-part component. This is what we would take this out, and I will show you guys in a minute. You would twist this. It's a little bit counterintuitive because, righty-tighty, lefty-loosey. In this case, it's the opposite. So for me to loosen this, I'll go to the right. And now I can take this out. It's like a locking mechanism. And the way this would work, we would put the ink right through here, and you will see there's a little stepper motor. Oh, wait, maybe some lights in here would help. That's why it's a little bit dark. You got them? Thank you. There we go. Yeah, that's good. Okay, so I don't know if you guys can see that. There's a little stepper motor right here. Can you guys kind of see that? Yeah, maybe? No? There's a little, feel free to get closer if you guys want to. There's a little stepper motor right here, and there's like a little gearing, like a little gear up here that would match with this gear right here. And after you probe this, a lot of this stuff is kind of have to be manually set up, which you will see what I mean in a minute. But once we put this in, the way this would work is it literally turns this. And as you see, when this turns, the plunger either goes up or goes down. Right now, it's going up. You see that? So when it turn counterclockwise or left, it'll be pushing out, which is counterintuitive. You would think, right will tighten it, which will go further. But yeah. So it works just like a syringe. There's a plunger. The plunger pushes in onto the ink and extrudes down from the tip. And we're going to set all this up. I'm just going to give you an idea. These are the parts that we have. Oh, let me pass this around too. There's some ink on it. It won't hurt you or anything, Okay. So this is what's called a burnishing pad, which looks like a sponge.
How do you get the ink out?
So the ink it's its own cartridge. So this is what the ink looks like. This is kind of like our conductor. This would be our ink. Oh, this has no ink in there. That's just the probe. That measures the height. Yeah. So this would be our ink, which we're going to go into the whole process of setting it up right now in a second. Where was I? Oh, yeah. So this thing looks like a sponge. And you will see what we're going to use this at the very end. Okay, this is more important. When I first opened the box, I thought this was garbage, like packaging stuff, so I was about to throw it out. I'm so glad I did it. I saw too many of them. It seemed odd, so I held back on it. Oh, maybe I need to plug in my charger. Wait a second. If you ever have any Eagle questions, the guy right behind you guys, he's the go-to person. I'm putting him on the spot. So if you ever need a Eagle guidance, that's your guy. Okay. So let me see. Okay, so to the very left, you can see these tips right here. Those are the part that I said they're very fragile and they like to break. Okay, let me show you how tiny these are. So don't take this out of the bag. Just look at it this way, and try to look at the exact tip of it. You'll see like the tip narrowing, and then it's like a very thin tip straight up. Look at that. If that straight tip breaks off, which it likes to break off, if that happens, that tip is gone. You can try to make it print. You can try to make it work. It will not work that well. I've tried. I have very good luck. You can try too. Let me know how it works. And they're very fragile, and they like to break. They really like to break.
And
So that's, yep.
And you said they break, they are almost sure to break if you're not measuring the
If the
probe to
like,
the height correctly.
look, if you put this in and don't mess with it, it'll be fine. The thing is, like, I'll show you a process where sometimes we wipe, because it does a test print before you do your actual print, and you have to wipe that off. And sometimes by wiping that off, you move the board a little bit, or something like it unscrews one end or something. That's when it will break, because now you have this board that thinks it's flat, but it's tilted in this one corner. When it gets to there, the tip is like on the board. So if anything goes up, it's just going to catch and literally break off. So, and that has happened with like 3 tips already. So it likes, and it's not like you would do it on purpose, or you can even see it. You know, it's very fragile. I almost think it's a design flaw, but don't tell Voltera that. It's a feature. Yes. And these guys right here, these are our clamps, so you can see them right onto here. These clamps are what hold the board down. Now these clamps have 2 sides. One with a thicker side and one with a kind of thinner side. Take a look at both, and I'm going to tell you which side is for what in a minute. So you can pass these around. One side you can see it's a little thicker than the other side, which is much thinner. The thicker side is the one you're going to have holding the board down or clamping the board down. So this PCB board, which we're all going to see in a minute, we're probably going to get a little closer. And when we mount the board down, you'll see that the bigger side, it's meant to just put brute force clamping the board down so it doesn't go anywhere. The thinner side, after we're done with the ink, so the ink, it's wet. So it's not like it's dry ink. Once it comes out, it's still wet. You can leave it there for 2 days and it will not dry. What dries it is if you bake it. What I mean by bake it is literally add heat to it. So this plate down here heats up to about 220 degrees Celsius. This plate right here. And it'll act as a baking board. It'll literally add so much heat that the board itself, the ink on the board, starts to solidify and kind of cure. And that's how we cure whatever we printed on this PCB. That's the process that we would use. Let me see, what am I forgetting? Oh yeah, so the difference is with these clamps, the thinner part would be facing the bottom, where are the clamps? Let me see. So these clamps, you see how the thinner side, right now I have the thicker side. I know it's hard to see. This is the thicker side. It will go onto the board like this, and the other side would go like this, and it would get clamped down onto the board. You see how the thicker side is up? That's the thicker side. So you clamp this down, and then you start the printing process. Once that's done, you carefully remove, because also another thing, which we will see all this, I'm going to repeat in a minute as we're doing it, it's still wet. And sometimes your shirt might touch the ink or something, and then it's ruined. You have to completely start over, because don't try to fix it, it will not work. You have to really just reprint it. And the printing doesn't take long at all, like 3D printers. It takes about a minute to finish a whole print, so it's not that bad. Yeah, so just the setup process is a little bit tedious. Now, once you're done with the printing part, you take these out, you remove the board from the side, and then you flip these to the thin part, and you have it sit on top of the thin part, so the PCB board is not in contact with the hot plate by this much, by this little thin piece. So this is kind of like a little table and you can see the board is sitting on top. Can we see that? And then we're going to see this more up close. Am I missing something here? Those are inks. We have different types of inks. We have conductor, and we have solder paste. So the conductor ink is basically the generic ink that you would use to connect lines. It's the ink that you would use to write things or symbols or whatever. It's still conductive. It's silver-based, I believe. But it's the kind of the go-to. The solder paste is, remember when I said we have these boards that you put components on top? So you put solder paste on certain pads, and then you place this component on top. And when you bake it, what happens is that the solder paste literally solidifies to the component and the board. And that way you have that already. You skip the soldering part. You don't have to do any soldering. The component itself fuses itself onto the board. Yeah. I think we covered pretty much anything. Those are just spare parts. Okay. 2 types of boards comes with the printer. 2x3. We have 2x3 and 3x4. Those are just the 2 type of boards that come. But you can use any type of board. You can buy any board anywhere. You do not have to use the Voltera ones. You can use any boards, but these are the 2 that we do have. And we have many of these. So for any projects you got to think of, we have plenty of boards. We don't have that many tips, but we have plenty of boards.
Can you cut the board later, like once you print on it, and then just make the board like special cutouts on it?
You can, no, it won't.
Not with like machine, not with that machine, but like for example,
Sure.
take it later. For example, you can make a controller. You know?
Sure, you can do that. You can cut that, yeah. They have like weird shaped ones sometimes. You can buy them like that. Yeah. Nice. So now let's go to the machine. This is the user interface that you will see when the machine is connected. This is step number 1. This is where we start. And let me get the smaller board because it will be a little bit easier to set up. I'll be right back. This is what the tinier board looks like. This is kind of what the tinier board looks like. Just so you guys have a better idea. You know, it's a little bit smaller. You can pass it around. It's a little bit smaller. It's usually all you need. You don't need more than that little tiny board. Okay. So now I think everybody should get a little bit closer to this area because it's a small work envelope. And you have 4 simple options you get to pick. What do you want to do? You want to print, solder, heat, or drill? We didn't cover any of this yet. We're just going to start with prints. So we'll go straight and click on print. And what I like about this is, first is then I ask you, it's straightforward. Is it simple or aligned? What this means, simple means a blank board. No previous features, blank. There's nothing else on it. Aligned means you have to align what features you already have in order to print the new ones. So it has to know, okay, I have holes here, 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 here. I have this feature right here. And then you'll find it. And there's a way to probe and measure where all these things are. For our purpose, we're just going to start with a simple one. And you'll just click on simple. What type of ink? You can see the ink. I know now I'm moving a little bit faster. Okay. So each ink will have a name at the bottom, like a smaller name. It's under lot. And this is Silent Centaur. I think that's what that's called. And if you have any more, like a whole bunch more inks, that's the one we have for ink. All we have is this kind, so that's why it's only there. It's usually the go-to. There's some other specialty ones you can go buy on their store online, but this is kind of the go-to. Now, you go into the board. What you're looking at is this. And the way you're looking at it is think you actually have this standing up front like this. So whatever the board would look like, you'll see like a little layer right now. You can move that up and down or whatever, you'll see. So do you want to load the last circuit? It remembers your last circuit, what type of ink or whatever. We actually want to go for Hello World, which is kind of the intro prototype. We don't need anything. It has a built-in Hello World sample. Okay? So if anybody ever take any coding course ever, you guys know what Hello World is?
Yeah.
It's like the first thing you ever do.
It's on like an online reader, online compilers. It's like default, like already
Yep.
written out for you.
This is pretty much it. So this is kind of like your first, if you're ever going to do anything here, Hello World is your first try. Okay? So, yeah.
How does this work with Hello World exactly?
It's your introduction to Voltera.
It just brings Hello World in the thing?
Yeah, it just writes here. This is just like a basic circuit. I'm sure there's something behind this. I think it's like an LED thing going on here. Is what this really is. But it's just like a basic circuit to get you know the basics. If you can print this, you can print anything. Okay, it's the same process. It might get a little more complicated, but it's the same exact process. So now we put Hello World. We kind of centered it in the middle. We're good. Next step. And now start getting even easier. You see, there's little clips that show you every single step you have to do till the very end. There's little videos walking you step 1, step 2. It writes it for you over there. It tells you what it is, and it shows you little clips of what to do. It shows you what a good nozzle versus you see the little extension that I was talking about earlier? You see how it's broken off now? I promise, if you try to calibrate it and make it work with this, it will not work. So make sure you make these tips. They're very, very fragile. So we have to clean it. I already cleaned this. There's a little bit of stuff on there. Here we can, I don't have what I can use.
I have Q-tips in my bag downstairs. Do you want me to run and get them?
No, you don't go downstairs. Here, what I use is one of the bad tips. I use one of the bad tips to just get in there. So the step, what these two are right here, the calibration switches are called limit switches. And these limit switches, it's basic, this one right here defines your Z height. This little kind of push button, that's how like it says, okay, this is my Z height. And then these guys over here, I don't know if you guys can really see them, it's very tiny in there, it doesn't matter. It moves to right and left, up and down, calibrating the X and the Y axis. So it goes for the Z and then the X and the Y axis. And you'll see this in action right now. I'm just gonna use one of the old tips to just get in there and just clear up a little bit my Z, because sometimes, since it's extruding as it's doing some of this stuff, some of it gets in there. And usually you'll be okay, because it's just a small layer, but anyway, always cleaner, better. So make sure that's clean. You didn't see anything on it. Usually the X and Y has nothing on it, so this looks okay. So are we checked that we have a good tip? I think I have like one left. One good tip. Yep. Okay, yeah. So I remember one of these, because look, actually, you don't really have to break off the tip to be bad. One of them, for whatever reason, the tip's still there, but it's just kind of clogged. And we try to unclog it, it's not liking it, it's not printing. So if you're having trouble, it's most likely the nozzle, it's the tip. If you're having trouble extruding, even if after all the adjustments, it's most likely the tip. Even if it looks okay, it's most likely something clogged in there, something not looking right in there. So that's, yes.
How expensive are the tips?
They're not expensive at all.
Can you order them separately as well?
Yes, you can. What happened? Yes, but the problem is we are a state school, and they are located in Canada.
Yeah.
State schools do not like to make business outside of the country. Okay, we like national, we like U.S. products, or any vendor that is within the U.S. These guys are only located in Canada, which to order even this thing, $10 or $20, doesn't matter how much it is. It's a whole paperwork trail they have to follow through.
If we're using it, something like happens and we seem to get a few extra, we bring in a few extra to replace the one that
Well,
might be damaged.
Well, you see, the thing is, if we're going to order once, which we will go through it, we have to order a whole bunch all at once. We have to predict ahead, So if we need 10, we'll order 20 just in case. Yeah. So let me see. One of these guys is a good one. Okay, so we cleaned up. Next thing I ask you is to mount the board, clamp the board down. So the way we clamp the board is you can locate these guys right here. See these screws? These is kind of like our clamping. The holders for the clamps down. Let me show you. You just thread these. They're usually in. Every now and then you will have to take them off. Do me a favor. Every time you take this off, these threads are so fine. And it's so easy to strip these threads. You guys know what stripping the thread means? Yeah. Okay, it's like, that's not a good thing. If we strip the thread, it'll probably jam it in and work for the first time. When you take it out, that's it. Nobody can ever go into that hole again. So what we got to do is, there's a trick when you're trying to get into a hole with threads like this. You know how righty-tighty, lefty-loosey? You go to the right to tighten it. Put it right on top and go to the left. And keep going to the left until you feel a little click. That means the thread just literally went all around and now sat where it's supposed to be. Now you can start tightening to the right. And go gently, vertical is fine. And sometimes you might think you're vertical and it looks vertical, but it's not. So just try this trick. I usually do this when it's fine threads like this. Just kind of feel it. Go to the left or counterclockwise and then until it sits, and then tighten it, okay? And usually once you have kind of these positioned, you don't really need to move them that much. So that's another thing. Okay, so let's make this a little more central. Let's make this a little more central. So I'm going to do one, and maybe we get a couple, 3 volunteers to try this. So I usually like to count how many holes I go down for the other side. So I'm just going to go 5. So on the 5th one, I think I'm vertical, but I'm going to go left till I feel a little click. And sometimes, if you've never done this before, not just this process, like with fine threads like this, it's hard to feel it. So I kind of felt the click. Yes, can you see that? Is my hand covering it? I felt the click. Now I know, look, it's going so smoothly, I know I'm okay. If you feel any resistance, even ever so slight, it doesn't matter. Just back off, check it again. There should be no resistance. I'm just doing, it should be just fine. So anybody wants to try this?
So I'm moving it 5 up.
Well, we were going to first let him put this one, and then you'll see what we're going to do. So on the 5th one from the bottom. Remember, go left. Go left first, as flat as you can, until you feel a little click, and then you go to the right.
To the left, and I have the pressure.
Yeah, you kind of hold it down as you're twisting counterclockwise, and you feel like a little click, then you can go to the right. You got it? There you go. That looks good. So that's perfect. So now remember that the thicker part is going to hold down the board. So we're going to look for the thicker part. This part right here, the other one is the thinner. That's for the baking part. We want the thicker part. I know it's a little bit hard to see. And we're going to put this, you see these little guys right here? That's kind of where the screw goes through. So we're going to place this under here, just like this. And now we're going to get our board. There's no real orientation you need to put this. It doesn't matter what orientation you put it in. It depends on your program. We can see that this kind of looks more like this than this way. So put it this way. And I'm going to lift this up. I'm going to place this. And I'm going to make sure that this falls within this groove right here. I'm not under this. There's a little slot that goes for it. You want to make sure you're there. Okay? So once you're there, then I will get the second one. I will place the second one on it manually. That's at least what I do. And then I see which hole kind of works best for it. So here, you want the next one. Right there. You see that hole right there? I will do that guy.
Both of those things have grooves, right?
Yes. What do you mean? The clamp, right?
Yeah.
Yeah, they have a slot on both sides. Now hold it vertical. Okay, now you know which one it is. You don't need this anymore. Remember, right? You remember which one it is?
Yeah, it's that one.
Okay, so go left first, hold it vertical, hold a little bit pressure down until you feel it clicking. Once it clicks, you can go to the right. You got it?
Yeah.
And then it should be very smooth going to the right.
Yeah, like you can just flick with
That's it, yep. Anybody else wants to try the last one? Are we good? Okay. So, I'm just going to do the last one. Now, I have big hands. That's not a good thing when it comes to this stuff. Okay. So you never want to tighten these all the way till you have the board. You kind of move it around. You make sure it's horizontal. For one, you got to make sure it's not tilted. I've done this before. It looks a little bit tilted. So make sure it's horizontal. Once you make sure it's horizontal, don't go all the way to one side, all the way to another side. Try to almost center it. You could go all the way down so you know if you're perfectly horizontal on that end. Whatever works best for you, just try to make sure it's horizontal. Okay, otherwise your board might come out a little crooked. So once that's done, what I like to do is I clamp one side and then I go to the opposite side and I clamp that side. All the time holding these in. I never really let go of this. And then I kind of like in a star pattern. And then if it moves, like I just did, just loosen it a little bit and just start over. It's easier if you go to the front of it. So just when you tighten it, don't be afraid to tighten this down. A little bit tighter is better than looser. Looser might make you redo all this again. So if you're worried if you tighten it over, not sure if you tighten it a little bit more. So just go always for that. Okay. So let me just clamp this down. And then once you start clamping these down, you will feel a bowing, like a little bow in the clamps. Again, obviously you're pushing them from the two sides, and then you have the one side. So what's happening is the clamp it's flat, and you're only squeezing on these something in the middle, so it'll do this. And that's okay to feel that. Don't feel like you're hurting the board or hurting the machine. Just, I always say a little bit over tighter is better than thinking it's a little bit loose. When in doubt, just tighten a little more. Yeah. Don't over tighten them that you also strip the screws. Only, never use tools, just always use your hands. You know, this can take your hands. Never use tools. So if you can do that, we're in good shape. Believe it or not, we're basically halfway there. That's very easy. Okay, so board is clamped. That's done. We'll go to next. It's asking you, okay, we need to probe. We need to know the height of this current board that you just selected. So, like I said, this is magnetic, so it's very user-friendly. The probe is, whenever you take the probe out, whenever you're not using it, put the cap back on. If you hurt this or you break this, we really can't use the machine anymore, and we have to order another one from Canada. So if McMaster-Carr takes a couple weeks, think Canada. Okay, it'll take a while, so just always put it back on. Everything, we have a replacement from the other one, if anything. This, we do not have this is only a one piece. If we mess this up, we cannot use the machine until we get another one. So always, whenever you're not using this, just put the cap on. That's the most important part, that bit. So when we're using it, take the cap off. It's magnetic. There's a little slot for you to hold it right there. You know, you can just kind of grab that right there. And the way this works, just get up close. You'll notice there's little contact pads. Can you guys kind of see that? There's little contact pads right here, and little contacts right there. You just want to make sure this goes right on. And again, there's 4 magnets. It'll grab right onto the rail. Just give it a little wobble to make sure it's nice and sturdy. It's all the way up. You know, it's low maintenance, doesn't need anything. You just put it in and you're done. But sometimes I like to give it just to make sure everything is in there, because if it's a little tilted, there's something in the way or whatever, it'll still probe it. But when you go to print, is when you realize you broke the bit because something was there. So take a little bit, an extra second, just make sure everything is okay. It usually is. But you know, it doesn't hurt to double check. So we're done with this part. Now what it's going to ask you is, okay, it doesn't know where you place the board in perspective to the machine's plate. So it doesn't know if the board is down here, up here. The way you do that, the machine will literally outline the area that is highlighted in here, in this software. So this part you have to be careful with. This part you have to tell, okay, the machine, you have to make sure that the outline is within the board. Not a little bit outside or almost, it's within the board. It has to be contained by the board. And you'll see what I'm talking about. So to outline, first it will find what the Z height is, and then the X, Y is, and then from there it'll go onto the board. So we'll just click on outline. You'll see it right now, it's going for its Z. It's going to measure the Z. Then it'll go for X and Y. I think it does this process twice. And within this process, after the outline is done, you never ever want to move the board. If anything happens to the board, you got to reprobe and re-outline. Okay, if you do not do that, you're probably going to break the bit. And I don't mean to exaggerate, I keep saying breaking the bit. It's just that really like to break. What happened? Trust me, this machine more than anything. So you saw how this was within the outline, but I saw it was a little bit more towards, oh, you guys couldn't see that because everybody's watching from this angle. So it was within the outline where actually, luckily, this worked out. Usually doesn't work out from the first time. But it's a little bit tilted towards the top. So what I'm going to do is I can just grab this, bring it down a little bit, and then maybe center it a little more, and then try to click outline again. Oops. So this looked okay. I think I can bring down a little bit more. This would still work because everything is within the board, but I'm a little bit of a perfectionist.
So checking if the outline of the board is valid is entirely done like by eyeball.
On you. Yep. Yep. It has to what? So the length of that probe is measured on purpose. Is basically the length of what the needle or the nozzle of the cartridge would be.
Yeah.
And then when it goes down to this little button that it clicks, it zeroes itself on that button. That's kind of like the zero button. Then when you place this guy, if you notice, there's really no context, nothing to send any signal. All it does is start extruding with the stepper. There's nothing. There's a lot of manual, and you'll see the next step is also more manual stuff. You'll see. But yeah, you have to kind of be on it. If you're not on it, you will not have a successful print. This is the first revision. This is the first ever tabletop circuit printer. Other than the big, like pick and places, this is the very first revision. And I don't know if you guys know much about first revisions, but usually you don't want to buy them. Okay, but there's the only one in the market. Nobody else does this right now. First revision, people are still learning. They're still building. This is still developing. So, yeah. So we click on next. We're done with that. Now it's going to measure the height of this probe. So it'll go and touch and send little, every time it touches, it'll kind of, there's a little, almost like a little limit switch internally. And every time it kind of touches the top of this, it knows where the zero of the machine is and how high this is, and it'll send a signal. Now it'll know how much off the board it should be. Does that make sense?
Yeah.
So the board is here. This is the plate of the actual machine. The PCB goes onto here. Now it's going to go touch the top of here, multiple areas, and it'll know the difference in height between the board, between the plate and the actual board. That matters when it goes to prints. You need that Z offset. That's what sets the V offset. So we click on probe. What I like about this is it gives you an estimated time. So it tells you, okay, it'll take this long. And it's usually pretty accurate. So you just take a look that, nothing looks off. It's always landing on the board. I'm gonna make sure it does that. And then this time doesn't run every 1 second, but it's pretty accurate overall. Like if it's a minute and 5 seconds exactly. But as you see, every frame will take up 2 to 3 seconds. So the reason why it's going all over the place is kind of getting an average of that plane that it's going to be printing on. So if it's more tilted or it kind of gets an average of the total plane. What do you mean?
What is the material? Just like regular plastic?
This is not regular plastic. I forgot the name of this, but it's PCB material, I guess. Yeah, it's made for this. Yeah, I will look up what the exact thing is. I don't really know. It's a good question. But what's important about this is, as I was saying earlier, this is a 2-layer PCB, so you can print on the top and the bottom. They have 3 and 4 layers. Like some of the motherboards have like layers within layers within layers in your computer, all of it connected with each other. It's insane. Yeah. So once this is done, it's asking you, okay, if you saw anything that went wrong, this looked pretty okay. It was always on the board. As long as it did that, you do not need to reprobe. But if anything went wrong, you just reprobe another minute and it's done. Okay. So next, it's asking you to take this off. You follow the little videos. Again, super user-friendly. It tells you exactly what to do in case you forget what you got to do that step. Please always make sure to put the cap back on. Once that's done, you click on next. And now this process is the part where we actually put the conductor or the ink in. And let me get some paper because this gets a little messy sometimes. 1 second. Okay, so this is another important process, and what has to happen here is, remember how we said visually, when you kind of have to find where the board is located in perspective to the software, kind of where to tell where it goes. And here you have to prepare the ink to come out immediately right after the machine starts printing. And the way to do that is, first, this is what the cartridge looks like. What we're going to use is this guy, and this is counterintuitive. You would go to the right to open this up. So you go to the right, you twist to the right, and then you can just pull it out. Okay, you can see it's a little, and then you have to sometimes wiggle a little bit. So even if it's out, see it's not really coming off, you have to kind of wiggle it. Once you see this green spot, nothing being held to it, you can just pull it, come right out. Make it a habit after you're done. You had a question? Make a habit after you're done to just kind of clean the tip. Make sure you're working clean, stay clean. What we're going to use is this ink, which we're actually running out. It looks a little messy because some of it was squeezing out, but this is down to about here, which is a lot. This is what a brand new cartridge has. About this much. They don't come full all the way to the top. They come by about this much. And the solder paste, I think it's even a little bit less. So that's about how much it has. Now, this is the part that gets messy. So always work with a piece of paper under you. Let me do this right here. Can we kind of see here? Can we kind of see? Can everybody kind of move it just for this part? Okay. And a tip. Now I believe one of these looks okay, but I think this is a good tip. And if it's not, we'll find out. Yes? Keep reminding me tomorrow. It's been reminding me tomorrow for a year. Thank you. So, you have the tip with you. You have this in the cartridge. So all you need is this assembly, the ink, and the tip. Okay? And step number one is counterintuitive. Twist to the right. Once you see this little green hook come out, pull it out. Open the front of this. You can actually open the back first if you want. So the way this is a twist. It's a twist off. You see this little teeth kind of grabbing on. I actually have to use a little more force. Even sometimes you pull this much, you're being gentle, it doesn't really come off. So don't be afraid to just pull on this thing. And then you have to unscrew the bottom. Make sure that you open this up first. Step number one would be opening this. Because this bottom sometimes likes to, get stuff out, and it gets really messy. So the way I do this is I slide it in, and the more you slide it in, the tighter it gets. So I use these little two edges as like a wedging force, and I just squeeze all the way in. Squeeze all the way in until it's not going to go anywhere else. Okay? You have to be all the way in. Then I open the tip. I get the tip out, and this is a hand. You can screw it in by hand. So there's a thread in there. There's outer threads in here, and you just kind of place it in, and then you just twist. This you can twist to the right. So right will tighten it, righty-tighty. Okay? And you get that. You just kind of, whenever you feel it's tight, you go like another half hour to an hour. You guys know what I mean by that? Like if it's tight at 12, you just go a little bit more. Just, it's not going to go further than what it is. It's set. It's not going to go anywhere, but you just make sure it's on it. And the next step is make sure this is backed out all the way. Okay, because if you put this in and it's not backed out all the way, it's going to start getting stuff out all over the place. So this is counterintuitive. You twist to the right to pull it in. So right will not extrude, right kind of pulls it in. And you twist to the left to pull out, to push material through. So we'll place this guy right through this way, and then just twist it in. And now the next step that you have to, this is an important step, is you have to twist it counterclockwise till material starts coming out of the tip. Once material starts coming out, you go a quarter turn back. So you keep twisting until you see material coming out, you feel it tight and material coming out, then you go a quarter turn backwards, only a quarter. because the machine will set itself to only go a quarter forward to extrude, a quarter back when it's done extruding. So every time it's going to extrude something, just like in 3D printing. Every time it's going to extrude something, and sometimes it's going to just pause. What it does on the pausing goes back a quarter turn. So that quarter turn has to be set. So I'm turning counterclockwise towards the left. Sometimes it takes a little while.
Looks like you're loading it on.
What?
Looks like you're loading it on.
That's funny. I guess so, yeah, that's a different way to think about it. Okay, so now I feel it getting tighter. And there you go. You guys see that? So, okay, now you go a quarter turn over, and you just clean the tip. And then when you clean the tip, don't do this. We just spoke about, the tip being fragile. Just lift this up, go from the top, and gently, no pressure, just pull out. That's it, just like this. And then some will still be extruding, means the plunger went a little bit in, but it's okay. This is okay. Just make sure it gets cleaned off. Quarter turn, that's all you need. Now you can place this here. I think the next step tells you to do that. I think we already did the next step. Let me see. So it says, okay, make sure you place, so place the gearing. Remember how I said there's a little gear up here? It's black, you really can't see it. When you put this in, make sure that the silver gearing of this guy meshes up with the black gearing of this guy, because that's what's going to be running it. If they're off or not touching, you'll be missing a step or something like that. Okay, so it usually clicks right in. It shouldn't be a problem. Okay, so I can see from up here it meshed right. We got this in. It's not going anywhere. So this is our test run. It's going to try to print this on the board. And then we have to do some live tuning. So I'm going to click on Next. And then when we click Calibrate, we're going to take a look. And we're going to see that this is going to start printing this pattern. So if you guys want to get closer, I don't know if you guys can see that from there. Welcome to get closer. And then you'll see how we're going to be adjusting how much ink comes on and off. And another part that's important here is this is the part where after we keep printing these test pieces, we have to clean the board. We have to wipe off whatever we put. Okay? We have to wipe off whatever we put with some sort of piece of napkin or something. But when you wipe it off, always hold the board down, because by wiping it off, I have moved the board before, because some parts are really stuck and they really want to go. When they're stuck, use isopropyl alcohol. Isopropyl alcohol will get it right out. So find some isopropyl alcohol from anywhere, get a little bit on, don't just dump it on, just get a little bit on the paper and wipe that area, it'll go right off. Okay? And then whenever you're kind of wiping the board, make sure you're holding it down, okay? Because otherwise you will probably move the board. So we'll click on Calibrate. It's going to find a 0 again, and it's going to try to do this pattern. What?
No, it has a little bit of the extrude. It got knocked off a little bit from the well.
Okay.
It's already extruding it a little bit. Is that in any way?
So sometimes when this thing starts, it kind of just positions the stepper itself. It should be okay. It usually should be okay. But what matters is when it prints onto here, that pattern must look exactly like this.
Yeah.
Like these lines are so close to each other, but should not be overlaying each other. You'll see right now. And then, yeah, go ahead.
No, I'm going to say, because if the lines are too thick, that means it's too close.
Well, you can adjust the extrusion right here.
Okay.
You'll see. So right now it's coming down. I can kind of see that's a little bit on the thicker side. You see how those two are in contact?
Yeah.
So what I'm going to do is I'm going to click the little minus sign right here and see if that helps anything. I did -1. You see how now it's a little bit thinner? I think it's still a little bit too thick though. So let's go to -2. Okay, so these lines are kind of still touchy. You see the bottom 4 lines?
Yeah.
How they're still touching? That's not good when it comes to this, because what it's assuming is you potentially can have lines running this close to each other. Yeah, go ahead. You potentially can have lines running this close, or different lines for different circuits that you do not want interfering. You can have them this close. We will never, I don't ever recommend having lines this close. Quite the opposite. I recommend you having thicker lines. have thicker lines and have more distance when you design your board, to have more distance between each connections. Because thicker lines will give you a better connection. And sometimes this thing is not always perfect. So what I'm going to do is I'm going to hold the board down from an edge. And I'm just going to wipe in the other direction. You see this? This likes to get all over the place. Without you noticing by the end, by the end of the process, it's all over the place. So hold the board down. It shouldn't move regardless, but extra safety. Just so you guys know, under advanced, when you go under advanced, all we have here, this is our Z height. The Z right now is off by 0.08 millimeters. That's how much is off. And this is the extrusion. I just reduced the standard extrusion by negative 20 micrometers. So I just reduced from what it should be by negative 20. And this is the adjustment so you can increase and decrease. You can increase by 5, increase by 10s or 20s. So if I do a plus 10 right now, this number will go back to 10, negative 10. I do a plus 20 right now, it'll go back to 0, as in the extrusion. So you can just adjust, and this is your Z right now. That's the Z height. Okay, so you can adjust all this. You can adjust all these variables. Usually, you really never want to get into here. You start needing to get into here when you're working with boards that already have had holes drilled and certain other components onto them. That's when you usually want to get into that part. Vito had to get into that part. I don't know what we were printing or doing. We had to get in certain components. The board was printing perfectly fine. When it got to this one corner, it just crashed. Literally, the bit just crashed because I guess the feature on the bottom or something created a little bit of an edge, and that was enough for it to break the bit. So that's when you adjust it manually. You have to, figure out how much feed do you need for the extra height, and that's experimenting, really. There's no real manual for this. So I'm going to do this calibration one more time in -2 and see if we're happy and satisfied with that. We can move over to the next step.
So you wiped it down, by the way, and it came off. When you actually printing the circuit board, you just let it sit for like hour 10?
We actually, at the end of the process, once we're done, we're going to unclamp it and we'll flip it and we're going to bake it. This board, this plate heats up to about 200 degrees Celsius. An hour of that heat will cure this ink and it'll solidify. It'll become. Yeah, it can move. It's okay as long as it's not touching anything.
But that's what I'm saying. Once you flip it, and
No. Tell me.
Once we flip it and you have this stuff, like for example this part.
But this thing has a little distance. Remember the thinner part that I said you're sitting on top? That's the distance that you need. That's a good question.
So it just generates radiation.
Correct, heat, yeah. So that looks like healthy lines. If you notice that first line that it made, there's a little break. You see that little break on the very first line? Can you guys kind of see that? On the very first line that it made under the squiggly stuff, there's a little break. Can you guys see that? If we have a magnifying glass, you'll see that that has no connection. And that's a problem when you're running a signal or something and the connection will just end there. So what you do in something like this is you look exactly which one it is. You see that little, it's hard to see unless you really focus on it. The first line on top of the squiggly things is kind of broken in one spot. So you can just go directly and, of course, there we go. You can just zoom in and you can just select the line you want to rerun. And I'll just select this line. And we're going to do this more. This is more not for the calibration, but it's more for the part when you're actually printing the circuit. Once you're done printing, if some parts need to reprint, you don't have to reprint the whole thing. You can reprint only those components or those parts. We just did that part. Now it looks connected. So I'm going to wipe this off one more time. Again, holding this down. I try to be efficient with paper. That's how I usually get it all over my hands. Okay. So, are we happy with the calibration? Yes?
I don't know any difference between the first one and second one. What is different?
The next time I did it? Or, no. We just reran it. The first time was exactly the same as the second time. We just did it again to make sure we liked it. We didn't adjust much. You start to care when the lines look more like this. this does happen when the lines sometimes will look like this.
You mean now?
No, right now now is fine. Now the squiggly line looked like this. Yes, the thing is this much, right? Or one more. That was awful, but anyway. It looks like this, and then you have double, and then the lines at the bottom. As long as it's connected, it's nice, and they're not in contact, as long as they're not touching each other, you're okay. So the first time we did it, we got lucky. It worked right away. But sometimes you'll see breaks and fading. Or other times, which also is a problem, you see such a thick line that when, like, let's say this is the end of this one. Okay, let's say this is the end. And then when it moves, it just absolutely connecting to the other one. And then the lines at the bottom don't look like lines like this. There's no space. They look like this. They look on top of each other. That's over extruding. That's a problem because sometimes when you have a lines with this much distance in between them, like you have a populated circuit, because you don't want those two signals interfering each other. So you want distance between them. But what I was saying earlier, which now this might confuse everybody, is you never want circuits, this tight, this much distance between them. Like in here, this is like the top of what the machine can do. They can do that close and have that distance between them. You usually want to have more spacing between the circuits that you make, more between the connections that you make, and then have thicker lines. Thicker lines with more spacing will give you a much better connection, way better connection that will last longer and more prone to the world and the environment. So always go for thicker lines with more distance.
So we are repeating because we want to make thicker lines?
The only reason I repeat is to feel better. It was okay. It worked the first time, nothing changed. I just wanted to do it again because sometimes, again, like you see the second time we did it, one line did this. And then I ran again that one line all over to make sure it's connected. Yeah.
What causes this, like, have little dotted lines?
So, okay, good question. Sometimes it could be a clog inside the nozzle, like this nozzle looks like this. Sometimes there could be a little clog right around here, like overflow, because you're literally just pushing stuff through here. That's literally what's happening. And then sometimes a little part that's been sitting there a while solidifies, or something, it's tough. And then it's just, you try to push through, you try to get in between, but sometimes it doesn't, then you have a little break. Other times, you don't have enough material pushing through. Like you see how this old one looked messy and stuff? Maybe some of it, like sometimes there's an air gap, like an air bubble. And that air bubble gets to down here, and then nothing comes out for that line. And that's how you have that little space. Multiple causes, multiple things will cause it. That's why you always kind of want to, like, every time I'm printing, I'm looking at it. If anything goes wrong, you kind of have to react. Again, it's a very it needs you to be in action, this machine. Yes?
So how do you fix something like that?
You run it over again. I selected this line, and I ran over again. And if it keeps giving you problems, like it under extrudes or it's continuously over extruding, the bit, something's wrong with the bit, you got to replace the bit. That's usually what I found to be the solution. Not always, but usually. Sometimes it could be the ink. The ink, by the way, good remembered, you always want to store the ink between 4 to 10 degrees Celsius, or 3, I think it was 3. Between 3 to 10 degrees Celsius. Always store the ink. So it always have to be refrigerated. So I keep them downstairs in the fridge, in like a little bucket inside the fridge. Always, because if you keep them outside, they'll go bad. So you always want to keep the ink within this temperature. Remember that. That's important.
3 to 10?
Between 3 to 10 degrees Celsius. Always store the ink within 3 to 4. This area doesn't, but no more than 10. 10 is the hottest. That's kind of. And then when you take it out, when you take it out of the fridge, you want to give it about 15 minutes for it to kind of, usually it's a little more in the harder, solider part. It's kind of started to freeze at this temperature. So you usually want to get it come up to room temperature about 15 minutes. Then it's good to use. That's why I pulled it out. I had it sitting down on the side while we were doing stuff, because you want it to come back to room temperature when you're working on it. But to store it, always keep it refrigerated. I thought this was a nozzle. I was like, what is the nozzle doing outside? It was a cap of some pen or something. All right. So did we wipe that off? Now we can go to next. We wipe the thing off, which we did. And by the way, as you're printing, you can still live adjust the board. And sometimes the test part can be perfectly okay, but when you come to actually print the circuit, you're having problems. That can happen too. So let's see. We're starting, so if you guys want to get close, take pictures or whatever you want to do, feel free to do whatever you want. The what? Did you just smell it?
I'm trying to get close. Focus.
Like, can you really see it?
Huh?
You guys will
Yeah. And I'm making
take two binoculars.
give it a little. Now I'm gonna make glasses, two glasses,
Oh my
and then
God.
the camera. I'm gonna output a display like magnify.
Remember, you can make live adjustments. I can't see. How's it looking? I can't see anything.
Can you print hello world?
Yeah, no, it's
not with solder, but like with the white ink that they use.
What other
You
ink?
know, like on some circuit boards, they have like white ink that like tells you A1.
You can buy any ink you want, put it in there. No problem. Yeah, as long as it's the right cartridge with the right feet to face the nozzle. Yeah. How is this looking? I can't see from here. Yeah? Okay. We'll see at the end. At the end, whatever lines need to pass over again, whatever lines need to reprint, or if we see something wrong overall, we can adjust. The only main thing that you always want to keep paying attention to while printing is make sure that bit doesn't look like it's about to break or go into the board, okay? Then you just click stop, which, by the way, stop is not an emergency stop. It takes about another 5 seconds after you click stop for it to actually stop. So if it comes down to it, I think you guys should just pull out, since it's magnetic, just pull out the nozzle. Pull it up. You know, it'll just come off. It's better than just clicking stop because the stop button takes a while for it to stop. Don't trust the stop button too much.
Maybe like, oh, okay, in case something's.
Yeah, I've had that happen to me before. I saw it crash and I clicked stop, stop, and nothing is happening. You know, it was just.
Just take the plug out.
I'm not gonna reach back. You see how big that counter is? That's a good idea too.
It's right over here though. Yeah.
You have you're better than me. I can't think like that. I just pulled the thing out.
Just put your finger on the nozzle. Yeah, just plug it. Just plug it.
Stop printing.
Just start yelling at it.
Yeah, there you go. That might work.
Yeah.
I've tried the begging. It didn't work.
That's really nice.
Is it what?
Oh, we don't talk about that, man.
That's the on-off button. That's all that button does.
We're not there. We're not. You did go over that. We're not there.
That's an advanced step. He's right.
That's what drilling and that's for advanced programmers.
That's beyond Hello World. This is Hello World level right now. I really can't see much, so I'm trusting you guys that it's okay.
You look over its chest. Just solid. No, you're good.
Yeah.
If anything is
Okay. So it's actually under extruding. I just looked at it from the top. You see those?
It looks a bit thin.
No, you see those pads? Those pads should be solid. It shouldn't be like with little holes like that. It should be solid pad.
Oh, okay.
And it's not a solid pad, so that means, you know, we have to increase. So I'll go in the plus. I'll actually go up twice.
Maybe the ink is about to end. It's really, really low.
It's not doing a very good job.
No.
Okay, we'll take a better look now after it's done, I guess. I can't see from here.
Yeah. Yeah, I feel like the machine is confused. I mean,
That's too big of an audience. It's not used to it.
imagine you being a circuit board.
Okay, let me see.
I'll be like, hold on, what do you want? No, I'm just kidding.
Okay, you see, this is not a good print. Let me show you guys why. Not a good print. Here, if you want to come here,
There's no love.
look at these. You see these holes right here? Look up here. This is supposed to be solid. All these pads are supposed to be solid. Look at here, there's a whole bunch of gaps. right?
It was fine here, but then it just.
The lines look okay, but when it has to fill stuff, it's not extruding enough. Okay, so what we do is one, we could wipe this off and start over, or two, just print over it. I increased the extrusion. I'll increase it a little bit more.
You can reprint.
And yeah, I'm just gonna click. I know I know what you're saying. You're saying just cover the lines. Fine, let's do that. So that, what?
There's an option there that you can reprint at a specific file.
Yes. So like, you remember how I said I clicked the one line? Look, if I click on this one right here, you see how that right now became green? I just clicked on the middle circle. I hold Control, and click on the second circle, or Shift. I hold Shift. As long as you're holding Shift down, you can select multiple, whatever you want to rerun. So these two holes or circles didn't look very good, so I'm going to click on those. Notice that there are 3 parts. What else didn't look good? All the pads. Unless you think you see a good one in there.
No, they all count.
Okay, so I'm rerunning all of these guys. So we don't have to rerun the lines.
So cool, you can just click on them.
Oh yeah. So remember, to click on them, you have to hold the Shift button. And to unclick them, you have to hold the Control button.
It's the coolest part of this. Is it not?
Oops. It's a little bit tough to work without a mouse. Okay, is that everything? Do we have Hello World looking okay? So I just held Shift down and clicked on everything that I want to reprint. And it'll highlight in green. Whenever you pick something wrong, the way to unclick it, don't just click it without Shift, because then it will just start over. Hold Control down and then click whatever you don't want, and that way to unclick it.
Can you control
So-
C the selection?
What?
Can you control C the selection?
Control C?
The selection?
I don't think that will work here, no. I haven't tried, but I just spent like a whole bunch of 3 minutes just clicking these. Let's try it after we print. Okay? Correct. Okay. So I also noticed I increased the flow from -2 to +1. That's a lot of increase. We usually want to go up by 1 or 2 max. I just did 3 because I feel like we can be a little generous in these spots. Okay, and let's try to see what that looks like. So notice it's not 3 minutes and 40 seconds, only 1 minute and 40 seconds to only print these parts. What? Well, we saved 2 minutes of our lives.
So wait, is there like a risk, like say you put too much of the paint on there, then could that?
The only problem that could happen is if you have 2 lines too close to each other, the too much ink will make them touch. That's the only problem that can be
But
Yeah.
you were saying to just as
when you're designing it.
usually to try to keep them spaced
Correct.
to minimize that.
Correct. Because when you can over extrude, you will never run into this problem.
Don't you have to clean out the button with this one?
Yeah, oh wow, that's a lot.
Because it was touching that part.
Okay. You see, you do have to clean that up always, but I'm not too worried because when this thing goes down, it pushes the button down. So this space usually will spread out, but yeah, you have to, for a better print, if we cleaned that up, it would have been better. But I think it'll be okay. Let's take a look, I don't know. How is it looking?
Definitely better.
That's much better. Yeah, you see how this now like almost nice and solid? So the pads are nice and solid. Hopefully the circle will be nice and solid. The circle is a big area to cover in a circle, you know, so. I said circle twice in the same sentence.
Yeah, I say so much stupid stuff in my
It's part of it.
I'm excited to see like the solid. Because I feel like with the small pads, it's kind of harder to see, but I feel like this is going to be a bigger improvement.
Let's see.
Yeah.
Is it better? I'm blind, I can't see. Does it look better?
Definitely better. I think the only reason I'm seeing like any sort of like reason that's not perfectly solid is because the nozzle is like
Oh, okay.
obviously there
Kind
is,
of
like,
swimming in there?
pattern that
Okay,
is, like going against.
fair enough.
Don't you need like a thicker nozzle for this? So like.
We only have one size nozzle. Yeah.
Are there
I don't know. Let's see.
Not just great. This is the very beginning.
Okay.
Could you imagine trying to?
So you see how this circle still doesn't look very nice? What I would do is,
Just Z.
what happened?
Or just Z.
Just well, that's another thing. You could bring it up a little more and extrude. It's probably a little too close. Or I would, because we increased the flow, I would clean this whole thing up and just reprint with a higher flow. Sometimes starting over will end up really saving you more time. And material, because right now we're trying to adjust these holes and keep adjusting these holes, and sometimes starting over, you might feel like it hurts, but it's a good idea. So when it comes especially to this machine, don't be afraid to just wipe it off and just start over. And it's not like 3D printing where you spend a whole day, you know, it's a couple minutes. So don't be afraid to do that. I think that's what I'm going to go for. I'm going to wipe off the whole thing and start over. Yeah.
Is this not neutral on here, or can you insert it from like?
Eagle, from Eagle. You need Eagle. Yes. So remember, hold the board. You'll see a lot of stuff. Okay. I'm going to increase the flow a little more. Let's try this. I'm restarting it again. Well, that didn't look good.
That looks much farther from.
I think that we are out of ink. No?
You cleaned up the holes.
Guess what?
Uh-oh. We still have circles to print.
You see how this looks right now? A little, like it looks dash. It's like it's trying to extrude, but it's not really extruding. I bet you that if we switch the nozzle,
Isn't the last nozzle that was good?
no.
It was
What? We have one more nozzle, one last one. Okay.
Let's leave it for HAB.
No.
They will need it.
This nozzle is the one I guess we've been using. Yep. So we had one nozzle. Remember when I said the nozzle doesn't really have to break off in order for it not to really work? And we had one of those laying around. I wasn't sure which one it is. I think that's the one we got. So I'm going to stop just so you guys see how long the stopping takes. I just click stop.
Took like 3 seconds.
3 seconds? Okay. So if you see it crashing, don't wait 3 seconds.
You have
Oh.
to predict the problems.
Yes.
So like for a second.
Yes. Okay, so let me work on top of here. So this is another nozzle. I'm assuming it's the nozzle that's the problem. So what? It could be, but we never moved the board, and it's not heated up or anything, so I don't think so. But let's try the nozzle first. If we switch the nozzle and nothing still changes, I mean, take a look inside this thing. Here, you can pass that around. There is, but you know, sometimes trying to clean them, you'll break them from the inside. Yeah. Yep. So same process. I replace the nozzle, go counterclockwise, feel some pressure. Or it could be that this ink is also old, by the way. Or it could be that we're running out of ink as well.
The ink only comes from one manufacturer then, right?
Yes, it's only them.
Probably
In-
infections in the mixture.
Which is in Canada.
Okay, so I think what happened here is that we ran out of ink because I'm squeezing and it's tight and nothing is coming out. That might be a problem, all right. What? So let's try the same nozzle again with a different cartridge. So let's try that nozzle. I'm glad we're going through this, you know. That's probably what you'll probably go through, so. I had one more because I knew this could happen. I anticipated this. We were pushing our luck with that one. So this is a brand new one. Okay. We actually want to take that off because we're going to put this in. So how do you take the top off?
The top?
Yep.
You do this.
Turn which way?
This way.
All right.
This.
That's it. Can you clean that tip?
Oh,
Does it take that out?
Plunger.
By the way, to take this out, yeah. By the way, to take this out, don't push with your finger. It's kind of really snug in there. What I do is against the piece of paper, I just push down until it comes up. Once it comes up, you can just pull. Oh yeah. Oh yeah, no kidding. Make sure once that comes off, so we went through a whole ink cartridge
How do you clean this?
with the paper.
You have to.
Quickly, do you go through an ink cartridge? Something like that.
We've been printing ever since, like, we've been printing for a while now. Yeah, yeah, it's not, it doesn't go, it's not that crazy. It actually is more efficient than you think.
It's not like you
You think I'll make it
It's
worse?
not. It's not at all. No, it's not. This is definitely a little bit.
I didn't want to break it.
Go down.
Micro Center, it depends. Mostly Micro Center though.
If you can break it, I think you deserve a medal.
We just emptied their whole 2.85.
6 months ago,
Yeah,
Yeah, there
we just got on the 50% off. Yep,
You want to take it in there?
that's exactly what we jumped on.
he wants the
Let me see.
Oh, sorry.
Okay, that's good. You don't have to go crazy. Just what matters the most is this tip right here, and just make sure the outside is okay.
Yeah,
No, it's
Okay, so
you have to take a toothbrush.
we'll just kind of pull this in. This new material.
like that cream that you get in the dentist. Clean your teeth. Thank you.
We'll put the same tip back. Hopefully it'll be okay. I don't think it's a tip issue then. And we'll put the plunger back in. We'll squeeze this. Oh wow, okay.
That's bad.
That was faster.
Oh, there is.
Okay.
Oh, God.
Told you it gets all over the place.
I'm
Okay.
good at worsening stuff.
Nah, don't touch your battery. That's funny. Okay, it's okay. That stuff wipes off as long as it's not dried. So we go counterclockwise.
You want a piece of
We
paper?
definitely
Yeah,
have
it's
flow. It's okay. So now I'm gonna go quarter turn to the right, clean the tip like we said before. Okay. We'll keep these guys, actually. I'll take these guys with me and let's try this again. I think we'll have better luck. Let me clean this as well. We'll see if we see a difference now. We should. Yes, wow, thank you.
Yeah, just a pattern there.
We should take some. Like, fine. How do we take,
Don't try it.
I'm just gonna send it to you back.
The what? If the nozzle gets clogged? No, you see the other one doesn't really get all dirty.
The other.
Uh-huh. I don't think the other tip is clogged. Oh, you mean the one looks okay? I don't know where that one is. I thought it was this one. It could be still this one. We'll find out now. Here, we'll find out now. What happened?
No, just saying that you make sure the teeth fit in and everything, right?
Yeah. Once I pushed it in, I felt it going into a position. No, it doesn't matter. This you can take on and off. That's okay. What matters is if you move the board, then you have to do this. So let's go back to calibration. Since we just changed the thing one more time, let's go back to calibration. You see how when I change this to 0, you heard a little hissing sound? That's just the controller adjusting the stepper. That's what you're hearing. So, oops. I didn't highlight anything, only the one line. So I clicked stop. This is still stopping. So that's why I said the stop takes a little while. I think the way this really works is that once it receives a job, it does that job, and the job they just received is calibrate. The calibrate takes a while. That's why it's in stopping. After it's done with calibrate, the next position to squeeze to is stop. So I think once it's done with calibrating, it'll go back to home and stop. So when you change the cartridge, yes. What you see, once we're done, we're actually hopeful this time it'll work. When you're done, you take that up, you flip it, and it'll bake for an hour. 1 hour of 220 degrees Celsius.
Yeah, you can take your whole day just to print, try and stuff.
Oh yeah, you can, again, you can go crazy over this trying, you see how time consuming this is? Once you set it up, usually is much faster than this. Like Vito and I have printed a couple things and we got them out of the way and it wasn't that bad. Sometimes we spent a whole day trying to print one circuit and we kept running into trouble. You know, but again, the machine overall is nice. It does give you an advantage of printing your own circuits. That's something, and the hot air balloon, you guys are like, you know, taking advantage of this because they are light, so they have to be light. They need the circuit. They don't need to put a whole breadboard. They put one PCB with everything they need, and they're saving so much weight. Yeah, so that's the advantage of this. Okay, so let's see how these lines print. Again, I reduce this back to 0, and I'll increase as I see it, as we need it. Okay, so those are very thick lines, but you see how they're divided? You see how they're not touching? That's a good sign. Let's see how the bottom lines look like. They're not touching. No, take a closer look. You see? So they're nice thick lines and in position. That's a really good sign. So now I think we'll be okay on our print job. So I'm going to wipe this. And now let's try to print. And we should hope, all right, we'll have to reselect the whole thing.
Stop the button. Panic button.
Let's see how long it takes. Okay, you wanted to clean it, go. You'll clean it this time, yeah. It'll get all over your hands. Remember, hold the board down. Okay, that's good. Perfect. So just highlight every feature that you want in here. We highlighted everything. Now we click start. But that first line looks really good. Let's take a closer look. I just sat on the thing. I usually put my face in there every time it's printing. You know, I'm part of the printing process. You really want to be active.
I'm moving your head with it.
I do. Oh yeah. I use my glasses as zoom sometimes.
Were you sent there hello world initially?
Look, it's the group that made this is the Kickstarter. You guys know Kickstarter?
Yes.
So it's a 5 people Kickstarter. There was some quarter, some hardware guy, and like they're super cool. They went to China. They traveled because China's like the capital of the world when it comes to circuit printing and PCBs. So they went there. They learned. What happened?
General manufacturing.
Everything is China. Yeah, that's true. That's true. So. Yeah. Okay. Look at what? Look at these lines, guys. This really looks different. These are nice, solid, straight. Like this is what the print should look like.
Yeah, these are
And it's a 0.
prime.
It's a 0. We haven't increased anything. It's the standard.
There's nothing altered.
This is exactly what it should look like. So that could mean there was 2 variables. That could be there's 2 variables now. We can never know. It's either we were running low in ink, too low that when it gets to the end it doesn't print well, or that the ink is old. We don't know which one it is, but what?
Or the extraction is too high or too low?
No, because that would have just made thicker lines. Like if I increase now to 1, you'll just see thicker lines. You'll still be good lines, just thicker. So yeah. But this looks much, much, much better.
Do you know what like the shelf life for the ink is when it becomes too old?
According to them, as long as you keep storing it in the fridge, it should be okay. I don't really believe that, but we'll see. If this one goes bad after a little while. No, actually, it did go through the whole thing, as you saw. Like it printed pretty okay till the very end. We never used any other ink other than that one. Yeah. Okay, bear through, guys. We're almost done. This took longer than I thought. How long has it been? Oh, we're okay. Okay, I want you guys to see these pads. Take a look at how these pads look like. You see the difference in the pads? That's what the pad should look like. Yeah.
I'm waiting for these circles. Those are gonna look so good.
The circle would look really nice, probably.
I'm gonna be Mike now.
You have to be like how Beethoven.
I
would
gotta
always
be.
hand to the piano. You have to just like.
You see it?
I gotta feel.
Right? It's nice, clear, solid.
Oh my god.
Don't get scolded by the camera.
Everybody will be commenting late to that. Like 148. The first comment, 148 late.
Lakey also always cameos in every STEM video. If you look at any of the Bergen videos, Lakey's there.
The circle. The circle.
Yes.
On his face next time.
Yes. Oh, that's much more solid.
Still is a little questionable, but maybe we need to.
Yeah, there you go. Oh, that's interesting. If it's mid-print, it kicks up for a sec.
Oh yeah, it steps up every time it finishes a path.
Yeah.
I think we need to redo the circles.
Yeah, because there's even a difference between the positive
Yep.
and negative
Yep.
circles.
So no, if you take a closer look at the circles, the top one didn't really print as well. Okay, the circles on the top one didn't really print as well. So we're just gonna highlight it again. Remember, holding Control down. We're just gonna reprint the 2 circles. Oh, and those 2 pads right there. I think everything else looks okay.
Oh, I see the 2 pads you're talking about. The
Wait,
ones to the
actually,
left.
even this, you see those little holes in the middle?
Oh, yeah, there's
When this thing stops, I guess when it pulls up, it's taking it with it. So let's see. We got these pads over here. Oh, we got this. Oops. This. So holding Shift down. I said Control earlier, I think. Holding Shift down and the 2 circles. Look at the screen, the circles are in 3 parts. Okay, so that gets defined in the CAD, not in here, but when as you're doing this in CAD, is when you define this. Is that everything we need? Oh, and these 2 over here. All right, so let's try this now. And I'll actually increase the flow to 2 to make sure it's, we got
So
some.
that's like a heavy adjustment to make, right?
Yeah.
2 or 3 is like the
Well, I've increased sometimes to 12, but like usually you want to increase by increments of 402 is what I meant. Increments. Yeah.
It would be nicer if it makes the cuts first and then just fills them.
If it makes the what?
Cuts. Like, you know how CNC machine works?
Uh-huh.
Imagine if you did the cuts like reverse and then just fills them.
But it doesn't cut anything. This doesn't cut
I
anything.
think, imagine if, that was much better in my opinion.
But then it will be another process. Yeah.
Why wouldn't it?
Does that look better?
Yes. Yeah. The first
There you
one,
go.
It looks like entirely.
All right, so I think we got a successful print. That was for the machine, right?
Now we're gonna throw a party.
Okay, so that's how the lines should look like. So you see how many adjustments you have to go through? Usually, that's how much you have to put in. But once you now get to this point, I can print 3 other circuits, and it will be okay. Once you reach this adjustment point. You see how we switched the ink, we switched the nozzle, we retune some things, we increase the flow. Once you get to the happy position of this setup, now I can just take that board out, print another one, take that board out, print another one, and it'll be just fine.
Actually,
So, yeah,
there is 3 more pads that probably need to be redone.
where?
The top 2 and 1 over here.
Okay, we can redo that. That's all right. I see what you mean.
No, we don't.
Oh yeah, that one especially, that first one up there.
So these two, and then, which one? Oh, yeah.
That's why
Bottom
down
right.
next to it.
Yep. This one, right?
These buttons, they're actually $10. You can get it on the Adafruit website.
I think half of the things in here is from Made of Fruit.
I will not.
It makes sense, it's a Kickstarter.
Yeah.
Kickstarter or Indiegogo?
What? Kickstarter. I'm sure they went on everything, but
GoDaddy.com.
Like, so you've been staring at the whole time? Not the,
all right. So as the final step,
Come on, this is a very beautiful button.
it is. It actually is a beautiful button.
leave the button alone, guys.
I want to press it.
Yeah, can we get,
What?
Can I want to turn it?
No, not yet.
can we get the button make colors?
As the final,
Colors?
what?
Can we have the button like do like colors, the whole color scheme?
This is like V1.
I'm not sure. I focus more over here.
LEDs are gonna have the button.
That's all we
I know.
really care about.
Okay.
But you were saying the final step?
Final step, once you're done printing the circuit, you see you inspect that everything looks nice, solid lines, there's no breaking any point. Now we have to bake this board. And this is the part where you have to be cautious because as I said, look, I don't know how, I tried to be cautious, but it's all over my hands. It just finds a way to get all over you.
Well, I mean,
Now you pour.
I think you specifically put the wiping everywhere, so hopefully.
I did it on purpose. So, untightening the screws that hold down the clamps, okay, then carefully pick the board from the sides, and then you want to flip it. But again, do the next steps and just do it in order. So steps number 1, take the thing out. Again, use these clips. So we will take this out. You want to go, remember, counterintuitive. So you want to go towards the right. I'm going to pull the plunger back. I want to have some safety room. And I will squeeze to the right. I'm just going to pull out. And then, look, it's pretty much on the cleaner side, to be honest. So we finished the first cartridge. That was completely gone. I would unscrew the front nozzle. Once you take the nozzle out, right away just put it inside its cartridge. Just that's the most careful. If you're going to be careful with anything, be careful with this, please. Okay? So make sure you don't mix the bad ones with the good ones. So far these seemed okay, both of them. It turned out, so this was the good one too. This is one of the bad ones. Yes. So once we're done with that, remember how we get this out? We just push it against a piece of paper.
Quick question for when the nozzles that have been used,
Mhm.
how do we store them?
Just put them right back.
So not the nozzles.
The stuff inside, you mean? Yeah, look, you could try to clean them on the inside. I've tried that before. If anything, I feel that damages it more than anything. So
Do we put it back in for the way we found it, or should we like mark it off that it's been?
just right back in here.
Okay, and then does it go in separate ones, or okay?
Just reuse it the next time until,
Okay.
hopefully it doesn't break, but until it breaks, you keep reusing the same one.
Okay.
Yeah. We are running low on tips, so don't break them. So just, yeah, you just push down, pull on this. Once this is done, just close it. Remember, we have to store these once we're done in the fridge. You don't want to keep these out. So make sure it's sealed from the top, because sometimes what happens is it kind of bulges itself. You think you locked it, but it really looks like this. Okay, just make sure it's airtight. Make sure it's airtight. It's kind of sealed in there. Make sure you clean. Just make sure you always keep your work clean. Don't wait to clean it the next time. It doesn't take that much. You just clean the tip, assemble the part back together. That's it. Just gonna, it's easier to clean it now than later. And once this is done, next step would probably be to unclamp the board. When we unclamp it, remember you want the thin part facing the bottom. So I'm just going to unclamp this, and always look at your hands. If you touch any little part on this board, it's just going to ruin the whole thing. So everything is hand tightened. Just make sure you loosen this up. Okay, so I'm just going to separate it like this. I'm going to grab the board. You can never be too gentle, okay? That's our final product. I would pass it around, except I'm sure someone at some point would just, So we'll do that after we bake it. So I'm going to keep this in a safe spot. And all you're going to do is grab this, and you're just going to flip it this way. And you see the thin part? This thin part is going to sit right up against this. So the thin part is going to be right up against the plate. And we're going to place that this way. And the same thing on the other side. Thin part, right up this way. You're going to push it as far between the two sides as possible. You're going to tighten those. Those don't need to be crazy tiny because they're just placeholders, not really holding anything down. They're a spacer between the plate that's going to get super hot and our workpiece. So just carefully, make sure you don't run into this. And now the scariest part is that you have to put this upside down. You have to put this way. Okay?
Oh yeah.
So sometimes when we get too close tightening this thing, you see how we were on the closer side? When you go to flip it, it doesn't fit. So we have to go one over. So do I have a volunteer to bring this one over? Go. So here, I'll hold it if you guys want to take a look. Yeah, turned out really nice. And the coolest thing is, once you really learn Eagle is when this really becomes powerful, because then you can really use it towards your own projects. Yeah.
Looks beautiful.
Camera person?
Camera person.
You don't know who's watching.
Wow.
That's Mrs. Camera Person to you.
I was really speaking to whoever was watching the camera, but all right, we'll make that work. We got it?
You know how sometimes in videos they put the bloopers first and then the actual video? You know, like in YouTube videos when you go and people put the bloopers first and
Oh,
then
yeah.
the actual video?
Yeah.
That's gonna be the first part.
She's the master. You got it? Remember, left till it clicks, then go to the right. It has to be nice and loose.
There you go.
Yeah. You got it? It's okay. You're doing good. Fine. Yeah, that's it. So, once that's done, we're going to put this upside down. That space should be all that you need for the ink not to touch the bottom, and it should be enough for it to cure and bake the board. So just put it, don't throw it or anything, just place it. Just put one corner down, just bring it down as gently as you can. At some point, you kind of have to let it go, but that's it.
Touch the,
No, that's the idea. It does not. It should not. Otherwise, it'll.
so that's why I was wondering.
But that's your height of you're printing on top is less than that thickness,
Okay.
which is key here. Otherwise,
What if it's thicker though? I feel like
then you have to redo everything and then make sure it's not. Or bigger spacers. You'll have to work around it. I don't see a reason why you would ever over extrude to the point where it will touch, because that thickness, like the thickness of that layer, that was a lot. Like that's big in comparison.
But I thought this was the thinner layer.
This is a thinner layer, but that thin is too much, like to how much ink you're putting. You know, it's still a lot.
It's still, okay.
Yeah. So
Does it get thicker? Sorry for.
no, go ahead. Go ahead. No. That's part of it. What's up? What was the question?
So when you bake it, it gets. A
It
little
actually gets
thicker?
thinner. It kind of fuses itself inwards. Yeah. Yeah. So no problem. Any questions, please just go ahead and ask. So now what you notice is this screen. And this screen kind of shows you the current temperature versus the reference of what it wants to be. At the beginning, I thought current meant literally current as an amperage. I was like, well, that's interesting, you know. But yes, current temperature. You see how fast, I know. How fast this is rising.
6 minutes? That's nothing.
Well, I don't think we're going to stick around for 56 minutes. I would not do that to you guys. But that's pretty much, once that's done, one last thing, very important thing. You never touch it when it's hot, but what is an indicator? The safety indicator that they saw that was the most obvious is this red light that you guys see around the bottom. Can you guys see that?
Yeah.
That little red light. That red light, what happened? Correct, yeah. As long as it's not red, you can touch it. And when it's red, don't touch it, okay? And the coolest thing is, even if you take the board off or whatever and it's cooling off, it's still red till I think it's about 40 degrees, I think, or something like 40, 50 degrees. 40 degrees, I think, is where it kind of starts. Then it changes to, I think, a light green, blue. So like a blue, so a blue color, and it pulses, that means it's safe to touch. What?
It is in Celsius?
Yes.
Like everything should be.
Yes.
Like everything should be.
So
American?
it starts actually fluctuating in that temperature. Up there, when you see it getting to the top, it'll kind of go in like a sinusoidal wave around that peak temperature, going between 220 and down to 200, going in between there. I think we're a little bit under that. I don't know. So it goes up and down, keeps that temperature within that range. Now, it's very fast in heating. I'm actually impressed how fast this thing heats. And as a final step, once this is done, you grab this burnishing pad, and it kind of acts as a cleaner / polisher towards this board, and then you just kind of let's say this is the final product. I don't think you should go crazy, but you should like definitely get in there and just make sure you cover, get every edges. It's important. I think it's a cleaning / polishing part, so it's definitely important for you to, like they stress that you have to do this as a final step. So one of these sponges, you just,
On the bake.
after it's done. After it's done baking, yes. Once at the end, when everything is done, the last step is this.
Oh, so it won't mess stuff up?
No. Once it's done, it's solid. It's not gonna go anywhere.
Okay.
That's what we're doing now. We're baking it.
Yeah.
Yeah. So once it's done, you just do some of that, and then that's it.
Okay.
Yeah. Any questions? Of what's the full finished thing? Yes, I have one actually. You guys want to see a full finished one? Yes. There's like a little, obviously there's like a little quiz thing. That's basically the questions and the whatever. So I believe I covered everything related to that. We're done. I think we're done.